Hi, everyone. Thanks so much for joining us. We're just letting additional participants trickle in to the Zoom here. My name is Sasha Stashwick. I'm a senior advocate here at the Natural Resources Defense Council, NRDC. I'll be moderating the discussion today. And I think we can get started. So welcome. Thank you so much for joining us. We're here to launch our new guide to state and local, to state and local low carbon concrete procurement. This is a project that's been spearheaded by NRDC in partnership with Columbia University, and you'll hear from the guide's authors, Chris Neidl and Caleb Woodall, in just a moment. For those that don't know about us, about NRDC, we're a nonprofit environmental organization. We have more than 3 million members and online activists and 700 lawyers, scientists, and policy advocates working to protect our environment and ensure that everyone has access to clean air, water, and the wild. I lead our industrial decarbonization team here at NRDC, and we have had a focus over the last 2 years specifically on decarbonizing the cement and concrete industries. And we've really been digging in particular, on how to leverage the enormous purchasing power of federal, state, and local governments to make that happen. Really excited to be launching this guide for advocates, policymakers, other types of practitioners today. Every person who's registered for this event will receive a copy of the report afterwards. We'll get that to you by email. And a few other housekeeping notes quickly before I kick it over to our authors and speakers. We are recording this webinar, and we'll post that recording to our website and include it in the materials we send to everyone who's registered for today's event. We have about a 25-minute or so presentation, after which we hope to leave a lot of time for Q&A and a good discussion. So please use the Q&A function at the bottom of your screen, not the chat function. And I will be monitoring the Q&A channel throughout the hour, and hopefully we'll have time for a good discussion. So without further ado, I'll introduce our authors and our two speakers today. Chris Neidl is a policy consultant for NRDC, focusing on state and municipal level industrial decarbonization policy and advocacy. In this role, Chris has helped lead legislative and regulatory efforts related to low carbon concrete procurement policy, including ongoing campaigns in New York, New Jersey, Virginia, and Massachusetts, as well as municipal programs in New York City, Westchester County, and Ann Arbor, Michigan. In addition to his role with NRDC, Chris is the co-founder and advocacy lead for Open Air, which is a global volunteer collective advancing negative emissions support policies through member-driven activism. Chris came to the low carbon concrete space in 2019, following a 15-year career in solar energy, which spanned diverse research, activist, and project management roles in North America, South Asia, Afghanistan, and East Africa. He's an upstate New York native and longtime Brooklyn resident, and he currently is based in Costa Rica. We're very jealous of that. And Dr. Caleb Woodall is a postdoc at the Center on Global Energy Policy within Columbia University, where he analyzes technologies and policies to advance carbon capture and removal. He earned his PhD at Worcester Polytechnic Institute by studying multiple approaches to advance carbon mineralization, including experimental work, techno-economic analysis, policy analysis, and youth outreach. Caleb also brings deep experience with the industrial sector, having performed work with the concrete, iron and steel, and chemical industries. He holds a bachelor's in chemical engineering from the University of Arkansas. And without further ado, I will turn it over to Chris and Caleb.
Great. Thank you so much, Sasha. And I should also say that in addition to being our moderator, Sasha really leads the work on the state and federal level around industrial decarbonization, and get to work with her and others at NRDC every day. So excited to, on the other end of the presentation, Sasha, we hopefully will have a good dialogue and get into the nitty gritty. So really pleased to be here at this day. Dr. Woodall and I have been working on this guide for a number of months, a lot of research, a lot of conversations. So thrilled to see it get out into the world, and hopefully it will be widely read. And what we want to do today is, this is kind of an unboxing, I guess you could sort of say, of the guide. We'll talk about it at a high level, the contents, but with the understanding, obviously, we're sharing the guide with you today. So we just want to kind of give you a flavor and an overview of the content, and then we'll get into the Q&A. So we're really excited to take people's questions, ideas, and feedback. So I'm going to go ahead and get started with the first part, which actually corresponds to the first part of the guide. And this is just a little bit of context on the concrete climate connection and how it really relates to public procurement, why public procurement really matters in the project to decarbonize concrete. And to start off with, I guess the thing that you really got to just kind of wrap your head around is just how incredibly important and pervasive of a material concrete is. I think we all intuitively know that. We live in concrete environments, but it's the second most used material on Earth after water, by far the most used construction material. We don't know exactly how much is produced globally every year, but estimates are somewhere around 35 to 50 billion tons a year are produced. And it's entirely unique. There's a reason why we make so much of it. It does things for the built environment that no other material can do so extensively. It has unique performance, supply, and cost characteristics, which also mean that it's going to be around for a long time, which is meaningful for reasons I'll get into in a second. And one thing that it's almost a joke within the concrete world here is that just to really distinguish between concrete and cement. And so these are related things. Importantly, they're tied to each other, but they're not the same thing. So concrete is the finished material that includes cement, but also has things like aggregate, sand, gravel, water, and other materials. And that's what we ultimately make stuff out of. Where cement is a really critical ingredient in concrete, and it's really relevant to the climate picture, but these are not the same thing. So we don't want to use these terms interchangeably. Now, what is Portland cement? Again, this is the thing we do want to focus on when we think about emissions reduction. It's the key kind of magical ingredient, binding ingredient. Portland cement is the dominant form of cement. It's been with us for about 200 years. This is what you add to these other materials that magically give it its real properties of, flexibility, strength, that is critically important. It really matters by application in concrete, but typically it's about 10 to 15% of concrete. But from a climate perspective, it represents about 80 to 90% actually of total emissions that are tied to concrete. And if you, based on how extensively it's used, and you look at that carbon intensity, is about 1 ton of carbon is produced for every ton of cement that's produced. That means it's a really non-trivial part of the overall emissions picture globally. It's about 7% totally, which if that was its own country, it would be the third largest emitter. It's larger than aviation, but we don't hear about it as much until recently, I would say. It's also a very difficult to address emissions source. So one of the things that we really want to stress and why we wrote this guide is that it's the role that the public sector can play in decarbonizing concrete beyond just legislation and policy is really, really significant, uniquely significant, actually. And that's because the public sector actually is the single largest user of concrete for public infrastructure projects, for sidewalks, et cetera. Over a third of all concrete that's produced in the United States is procured by local, state, or federal government. So it's a major purchaser. And also governments at the local, state, and to a certain extent federal level are the real arbiters of important standards, specifications, and building codes, which really determine how we use concrete. So there's just an incredibly important, uniquely important role for the public sector. So the decisions that it makes in terms of how it procures concrete are meaningful both in decarbonizing its own substantial concrete-linked emissions, but also but the choices that it makes will have a ripple effect more broadly throughout the economy. And what we've seen, while it took some time, there's been a lot of catch up just in the last couple of years. While me and Sasha and Caleb were working on this, the policies that have started to focus on concrete procurement, climate-linked policies that related to procurement have popped up all over the country. So those are either state or municipal policies that have either been enacted or are being advocated for are now all over the country. And I'm probably missing some here. I feel like I learn about another one every week. And categorically, those policies differ. Some may be familiar with the Buy Clean model, which was started in California. It doesn't include concrete and cement yet, but it's been replicated in Colorado, and Washington's being proposed in Maryland. A little bit of it is within the current New York proposed New York policy. Then there's another category of legislation called the Low Embodied Carbon Concrete Leadership Act, which is another approach to procurement. Started in New York State. A version of that passed late last year. There's a really exciting version of it that's been introduced in New Jersey, which we hope is close to being passed. And now a successor to that, even in New York, as well as in Illinois. There was a bill that was introduced. It's ELECLA. And then there's various different states and municipal governments that are just trying to specify particular mixes for concrete that are lower carbon. We're seeing that right now as we speak, actually. There's the Office of General Services in New York is having a webinar about their proposed green specification, which is actually an excellent one. And that's happening in various different places throughout the country. And then you see on the municipal level, a lot of support resolutions. Honolulu really got that started a few years ago, where they just articulate an intent to try to use lower carbon concrete for municipal projects when possible. The U.S. Conference of Mayors adopted that resolution to support Austin, Texas. Locally here in New York, you have Hastings-on-Hudson, Westchester created that, and Ann Arbor, Michigan as well. And we're seeing that pop up in various different parts. So there's a lot of different varieties that we were able to look at when we came up with this guide to try to streamline what we think are best practices. And actually, in the guide itself, one of our appendices, appendix number 2, kind of gives, and there's a couple things that have popped up since we published it, that will give you a kind of a rundown of different things that are happening throughout the state and sort of relate them to our recommendations. So that's something you can look forward to when you download the document. Now I'm going to hand it over to Caleb, who is going to first kind of establish what are some of the key terms, definitions, and concepts you really need to kind of know in order to really get into this subject. So I'll hand it over to Caleb.
Yeah, thanks, Chris. If you go to the next slide, like Chris said, there's a few key concepts that you really need to understand to develop a really good low carbon procurement policy. And the first one is embodied carbon. So when we're talking about the next slide, when we talk about emissions of concrete, what procurement policies are really looking to alter right now is embodied carbon emissions, and that means the emissions that result from producing a material. That's as opposed to operational carbon emissions that result from utilizing that material. So if you go to the next slide, the embodied carbon emissions really range, you'll hear the phrase like cradle to gate. So all the way from extracting the raw materials from the ground to using them to produce key ingredients of concrete like cement and aggregates, then transporting those to the manufacturing facility and manufacturing the concrete product itself. In the case of concrete, the majority of embodied emissions are from cement production, and the majority of that is from process emissions, which is a result of the chemical reaction when you heat limestone to really high temperatures. Chris alluded to this earlier, that cement is a pretty hard thing to decarbonize. You can't just input low carbon electricity or low carbon heat. A lot of the emissions actually come from the chemical reaction, so it requires some other solutions. And then going to the next slide, how we're applying that to concrete, producing low embodied carbon concrete. It's important to know that's not really just one type of concrete. There's a lot of ways you can get to produce low embodied carbon concrete. Looking at the next slide, there's actually a whole lot of, there's a large array of even different categories of methods to produce low carbon concrete. And next, showing that this ranges from making modifications to a concrete or a cement plant, using less cement in concrete, using different types of fuels, or even using a different type of technology called carbon mineralization to store CO2 in concrete materials. A lot of these, there's a lot of options that are already available today, and a lot of other options that are still being developed and will be much more prominent in the near future. And you also see this, and there's a larger description of this in our report of the varying degrees of how these different methods can impact and reduce the emissions of concrete. The really neat thing on the next slide is showing that a lot of these methods can also kind of be stacked together to even further reduce the emissions of concrete. And like I said, the next slide, our Appendix 1 goes into pretty good detail of the different methods of reducing embodied carbon emissions, and how each of these can be used. So how to measure the embodied carbon emissions? Our best way of doing this right now is by producing an environmental product declaration, or an EPD. So the next slide shows that an EPD is actually defined as a type 3 environmental declaration, as defined in ISO standards, which stands for International Standards Organization. But a couple of different ISO standards that define these EPDs, and what they require. Well, an EPD is essentially akin to a nutrition facts label on food, where for a certain manufactured product, it defines the different environmental impacts of that product. These ISO standards require that the EPD be verified by a third party, and that it adheres to a product category rule. In the US, the National Science Foundation has developed a couple of product category rules for cement and concrete that a procurement policy could call out when requiring when talking about EPDs. The next slide, even further, a really good, robust procurement policy might also call for EPDs being product or supply chain specific. And what that means, a product specific EPD requires that data be used specifically for a product from a specific manufacturing facility, rather than industry average data. And the reason why that matters is the different kind of process conditions and materials are used in different concrete products across the country. And so it's really important that you use data from the specific location where it's made. And similarly, with supply chain specific EPDs, that calls for specific data of the ingredients that are used along the supply chain of that concrete. Which in the case of concrete, we're really talking about cement, getting specific emissions data from the specific cement that's used in that concrete. A procurement bill in Washington state would require supply chain specific data for components that contribute at least 80% of a product's emissions, which is essentially a cement in this case. And then finally, the way we talk about emissions here in EPDs is in terms of global warming potential, or GWP. So that's just the way conventionally EPDs show emissions, and it's in terms of kilograms of CO2 equivalent. So that's just a way to kind of put all of greenhouse gases on a level playing field, where CO2 is the more common one on a volume basis, but you also have methane and nitrous oxides that have a stronger global warming effect, and they also need to be accounted for. So I'll hand it back over to Chris now to talk a little bit about some procurement design principles that are really important in making procurement policies.
Great. And just to stress again, all of the terms that Caleb just covered for us are described in greater depth in the report as well. So now to get into, when we think about, we survey the landscape of the different policies that have emerged municipally at the state level, and talk to the designers of that and how they've been implemented or how they're being proposed to be implemented, we realize that it's important to not just think about them in isolation, but what are they anchored in? What are the principles that really inform them? And through these conversations, and we describe them in depth in the report, there's really 6 kind of design principles that overlap, I think, that really kind of inform good policy. A really key one is we have to say concrete is a unique material among building materials, but it has to be assessed on its own terms when we're thinking about decarbonization as a material, as an industry. And it also has to be accepted that it's going to be here for a long time, which is quite different from some of the other sectors that we're trying to decarbonize, like electricity and mobility, where the idea is to replace it wholesale with other options. Here, it's about reforming and evolving and changing this material to make it lower carbon. And that has real implications from a policy perspective. So you can't just impose sort of frameworks or ways of decarbonizing from other sectors. You really have to look at the details of concrete in order to develop a pathway forward. The other one too is that we have a lot of things off the shelf, as we lay out in the paper and as Caleb has already discussed, that can immediately reduce carbon dioxide. And any policy today for procurement should be ensuring that those best practices are factored or are required. But it should also be a policy that has an open door, that as new innovations continue to come over time, that it's flexible enough to incorporate those over time and even encourage them over time, which we think is an incredibly important piece of good policy. Another part too, which might seem like it goes without saying, but it's really important, particularly if you're approaching this from a climate policy decarbonization perspective. There's a lot at stake with getting procurement and specifications for concrete right that have nothing to do with climate. This is the foundation of our built environment that can't just be tampered with whimsically. So any climate objective that we're trying to achieve has to be rooted with, constrained in, and matched with broader public interest objectives around cost, around safety, around quality and durability. And this involves really directly having conversations with the experts and people that are in the relevant fields. Those are the people that make the concrete, their providers, the civil engineering profession, both within the public sector and outside of it. You really have to have these conversations and these folks at the table, informing the policy so that it's real worlded and so that it's fair and that you can avoid important, unanticipated negative impacts. So having those conversations with stakeholders is critically important. Another one too is, as we'll talk about, is that concrete is highly localized. The material, if you're in the Northeast, you have different things that you need your concrete to do than if you're in Arizona because of environmental differences. And so when you're coming up with things like guidelines or maximums or thresholds, you have to derive that from data about concrete in that area. So you really have to develop your numbers, not in the abstract, but from what is actually poured in the area where you're making policy. And then we put this last, not least, but really almost most, is that there has to be just a do no harm principle that is firmly in place. Not everything that reduces carbon necessarily delivers other goods. There can, in certain cases, particularly around fuel swapping. The fuel that's used in cement is most commonly coal and natural gas, but there's proposals to use, and it is used around the country, hazardous waste, tires, things like that, where those may actually be less carbon intensive as fuels, but they might produce more significant air quality issues that can impact local and even regional communities. So these have to be considered when we're trying to promote low carbon concrete, that it doesn't come with trade-offs or extra burdens for air quality for communities or for ecosystems. So these are the kind of core principles. Again, we articulate them in more depth in the paper, but really important to anchor our thinking in these principles. And so now we'll get into the building blocks that we think really arise from those principles and from real world conditions. And the schema we came up with in our guide is we have sort of building blocks for that are really sort of separated into two main buckets. We have 5 different building blocks, specific policy levers that are divided along things that we do with actual material specifications, our rulemaking around that, like what are we saying should go into concrete? And then the other one are real procurement decisions that you can build into your procurement program that are incentives or mandates that we think drive things in the right direction as well. So I'm going to just quickly describe those first 2 on top, the material specifications, and then I'll hand it off to Caleb, who will talk about the 3 building blocks in the procurement decisions category. The first one is one that has been slowly making progress in different jurisdictions around the world and in the country. It's critically important. And the reason why I have it as number 1 is because it kind of underlines a lot of the other things. And this is what we call performance-based specifications. So specification is what we're asking someone to deliver, what the state might be asking concrete producers or contractors to deliver in terms of concrete. This is a great quote from Lionel LeMay and some of his colleagues. Lionel LeMay is the policy director at the National Concrete Ready Mix Association. And what we're talking about performance-based contrasts with what the typical or conventional paradigm is, what are called prescriptive specifications for concrete and other materials. And unavoidably, if you spend any time in concrete, there's just an obligatory baking metaphor that you have to use. But what prescriptive specifications is essentially almost like a recipe, is the way to think about it, where the buyer of concrete is saying, this is specifically what we want in concrete. So they're laying out the ingredients, this much aggregate, this much cement, et cetera, prescriptive. And the problem with prescriptive is we're trying to change this material over time, like we said with principle 2, we were trying to evolve the material, is that if you prescribe it too heavily or too narrowly, that sort of crowds out or limits the ability for the private sector, for contractors, or for agencies that are asking for concrete to actually allow that innovation to happen. Really sort of closes the door, rather limits it, right? So the alternative to that is what we call performance-based specification, where you're not saying, I don't care, let's just take a cake, what you put in it, but I want it to do certain things. I want it to be creamy. I don't want it to be too fattening. I don't want it to be too filling or too sweet. You're saying what you want it to do, and then you're leaving it to the provider to come up with what's going to go in to the material to do that. And so in the case of concrete, obviously not quite a bit different from cake. Those might be, PSI strength requirements, chloride ion penetration, shrinkage limitation parameters, and other things that might be specific to a particular region. You lay those out, and then you're giving the provider greater latitude in what they can actually put in. And that includes things that lower cost, boost the actual durability, but also lower the carbon footprint of the concrete. And this is what we think is the key with performance-based specification for really allowing for that innovation and transformation over time. Without it, you're much more constrained. Another one that really relates to that in terms of enabling innovation is what we refer to as accelerated evaluation for low carbon materials. So even if you have a performance-based specification, there are still limits to what states basically approve in terms of materials and methods. So in different states, different agencies are empowered by that. In New York, in most states, I think it's usually Department of Transportation. They might have a materials division where they will evaluate different materials over time and then add it to this list of what can be used in it, both materials and methods. And the way that this changes over time, sometimes that's internally, that the agency will be exploring these independently, but also providers of materials can actually apply to have their materials at their own costs, usually tested, evaluated, and then ultimately approved or not approved by the agency. And one of the things that we've noticed when you talk to some of these material providers is that often because of constraints on resources within agencies, or sometimes just because there's not a requirement, there's a lot of delays, or even worse, just uncertainty. You're not sure when your material is going to get evaluated, how long that's going to take. And that translates into sort of what you're going to decide to do. Are you going to focus on that market? Are you going to be able to participate in that market? So what we're proposing is for that evaluation, when it comes to low carbon materials, if a provider is able to submit a third-party life cycle assessment that clearly demonstrates that there would be a reduction in carbon from the use of this material based on a third-party assessment, then let's expedite those applications. And that really depends on where you are and the type of material. In New York, for instance, we're proposing in our new bill a 6-month window that if you submit it, that the providers should have some certainty that they're going to at least get an answer within 6 months. And we think that is really, really critical to getting more and more materials, low carbon materials listed on those materials list, and therefore give a greater palette of low carbon options for providers who might want to include them or specify them in projects that they're doing for the state. So now I'm going to hand over to Caleb, who's going to get into the procurement decision building blocks.
Yeah, thanks, Chris. So, just as it's important to, look at material specifications, now you have to look at, what decisions can we make in the procurement process to help encourage use of lower carbon concrete. And the first off, what we find to be really important, and the first step of developing low carbon procurement policies is requiring EPDs to be submitted with construction project bids. And this really, should help facilitate that collection of local data. We've already talked about a few times of how the emissions of different concrete mixes in different areas of the country will vary widely depending on material availability and local climate. So it's really good to develop a good procurement policy to be able to collect data on the local materials and have a good idea of what are the capabilities and what are the emission levels of different concrete products. And next slide. For a concrete manufacturing facility to add EPD capabilities to their facility, it can cost a considerable amount of money, depending on how a different subscription plan or how many plants you're setting up with EPD capabilities. It can range all the way up to $8,000 per plant. So another thing to do in a procurement policy is to provide tax credits or rebates to these facilities. A policy in Portland, Oregon provides rebates of up to $3,000 per plant to lessen this burden. And the next slide, after you've kind of collected this good EPD data based on local products, you could inform a maximum threshold of emissions that you can set, so that any construction bids that are bid to the local or state government have to be at least under this maximum GHG emissions threshold. And like I said, it's really important to inform this with local EPD data, not just on national averages. So the next slide it's also important, if you're going to have this threshold, to go ahead and make this threshold become more stringent over time. So as these different technologies become more available, it should become easier over time to decrease the emissions. So we want to keep pushing those emissions downward by increasing the stringency of the threshold. In the California and Colorado Buy Clean policies, they each have within the policy to reevaluate the threshold every 3 to 4 years, and they can only bring down the threshold. They can't bring it back up to allow more emissions. And then finally, once you have this threshold, what's really important is to, we want products to at least meet that threshold, but it's, it would be ideal to even push and encourage even lower emissions than that. So what we can do is add high performance incentives to the procurement policy. You see in the next slide, without any incentives, a policy with a threshold limit would allow any any bids that meet that threshold limit to be eligible for selection. Usually after that, you'd be looking at which one is the cheapest. So here it would be that 10% below bid right there. But with an incentive like a bid discount, this would reward the lowest emitting bids by evaluating that bid at a cheaper price. You can evaluate it at 10 to 15% lower than the bid's actual amount, and then evaluate all of the bids. And in this example, the lowest emitting bid actually becomes the cheapest bid after the bid discount. So, this policy is actually inspired by a program that's, already exists in the Netherlands, and it's been proposed in an older version of the LECLA bill. But another option is a performance bonus that would be enacted post-construction. So, in this case, a bid would be selected based on meeting the threshold limit. And after construction, the emissions of the project would be reevaluated. And if the emissions were actually below what had the initial emissions level that had been proposed, the contractor would receive an extra bonus for over complying with that threshold. And this type of bonus we've actually seen in the Federal Highway Administration's National Highway Performance Program for doing what's called an innovative project delivery, like an accelerated delivering a project in an accelerated amount of time. So, you know, it's not a brand new policy, but yeah, it's something that has been proposed in new versions of the LECLA bills. Yeah. And yeah, like I said, like Chris and I were saying, you know, we have 2 different types of building blocks, and we really think that all of them are really important to develop really robust policies that give the highest strength of being able to enact low carbon concrete technologies. And yeah, now I'll hand it back over to Chris to talk about some dynamics of how these different building blocks can play together.
Great. And again, this is just a very high level overview. All of these building blocks are defined and described, and their variations in greater detail within the guide. So one thing I just want to conclude with is that while each of these building blocks are discretely impactful, they all do something valuable. One thing that is really interesting about the first one that Caleb was talking about around mandatory EPDs. We found that just by requiring EPDs, that isn't just good for data collection, it actually leads to lower GWP scores, because if you have to reveal that publicly, it creates an incentive to try to shave off some GWP, even if there's no incentive for doing so. So it's just, but the key part is that while they're all distinctly valuable, there's dynamics between them when you combine them. So we actually recommend this is a full suite of policy levers because they work together in really interesting ways to enable and amplify each other. So I'll just give you a couple of quick examples, which are described at length in the guide. One is that when you require EPDs, as Caleb had mentioned, that is a data stream that changes over time. So that means that the agencies in the state or the municipalities start to see this really particular data about what are we seeing locally about how different types of inputs or carbon reducing solutions, how do they start to appear? And can that start to give us a sense of what is an appropriate place to set our max GHG threshold within our state over time. So just a great source of data to inform that threshold, but it also allows us to think about how ambitious we can be with those high performance incentives as well. It can help you tailor when you set and how you set eligibility for different incentives as well. So those are very much tied together. This is a critically important one that I can't stress enough, is that if you want to drive innovation, and particularly if you want to introduce things like high performance incentives, either a bid discount or a performance bonus, you really have to open that up and really fully seize the opportunity of that by adding performance-based specifications and accelerated evaluation, as I said, because then that liberates the provider to actually consider a multitude of different materials. If you don't do that, you have relatively marginal things that you can actually do to reduce carbon, mostly around just your cement, the cement you select. So that's a really important dynamics between these building blocks. And then lastly, which I kind of just referred to, but these maximum GWP thresholds, if you set a maximum GWP GWP threshold that is already green, let's say it already is better than the status quo, then when you introduce those incentives, it means that you're kind of taking off the table the lowest hanging fruit, and you're incentivizing things that go beyond those. So when you create a threshold that's already has sustainability value, already has a climate reduction, emissions reduction value to it, that means that the incentives just by design are more stretched. They encourage providers to look at things that are maybe not the most obvious or standard already. So these are just a few important dynamics. And as these get implemented comprehensively, we're certainly going to find other dynamics that actually apply as well. So it's an important thing to, I think, really look at the more than the sum of the parts reality of these building blocks. And again, sorry, all of these are very much, included in detail, very practical sort of detail that I think within the design guide. And with that, I want to thank you. That wraps up our presentation, and we can go ahead and get into the Q&A.
Thank you so much to Chris and Caleb. There's some nice questions in the Q&A already. If others have questions to ask, please do use the Q&A box. And I might just kick us off. You know, Chris, you showed a map early on in the presentation just to show that, you know, there's kind of action and innovation around this theme popping up all over the country. And so I'm curious, where are you seeing, you know, real leadership on this front in terms of these procurement policies?
Yeah, and I'll even add a little bit more to that. That I think this could almost be a principle unto itself, I think, is that it's so important that whoever's trying to think through this stuff right now in a particular place is looking sideways for what's happening, you know, in other states and other municipalities. And also to really acknowledge the history. You know, these types of policy innovation and efforts don't just happen in a vacuum. They're driven by particular places and people, you know, so certainly while Buy Clean in California does not yet have cement and concrete included in its materials, hopefully that will happen. That is one bit of leadership that we're hoping to see this year. They started this whole model of, you know, global warming potential thresholds for materials. And so they created a paradigm that's been replicated. You have within California as well, Marin County, California, people like Bruce King and many other people out there developed a low carbon building code that also links to performance-based specification. So that really, really important precedent. Portland, Oregon. So there's been a lot of really, really great work locally in the region where Sasha and I are. You know, certainly you have to really give hats off to the Port Authority of New York and New Jersey, who's been really implementing in phases low carbon commitments around concrete. I understand that they're going to be adding to that policy quite soon as well, making it even more robust to include some of the building blocks that we included. And right there in the neighborhood, both, you know, New York and New Jersey, the current legislation that they have introduced, which are variations on the LECLA, which but also include, in the case of New York, it's really all of the different building blocks that we proposed are in legislation that's introduced in New York right now. That's, if that passes, you know, that will be the model policy, I think the best one in the country. But I really want to give credit to where New Jersey is right now, because New Jersey has a lot of those elements in place. And if that passes this session, that will definitely be really setting a really, really high bar that has an incentive policy in there. And that's been driven by some really amazing activists at the Open Air Collective, Sue Dorward and other folks, with a lot of involvement from NRDC as well. So that's when I look at it right now, I think particularly in the immediate term, because of what's going on legislatively, definitely keep your eyes on New York and New Jersey. And also we should give a shout out to Colorado, which did implement a Buy Clean, past that legislation that does include concrete and cement. So they definitely have set the bar pretty high as well.
Great, thanks. I'll hop around the questions a little bit. The first one, though, is about frameworks developed for calculating life cycle emissions. So have there been any frameworks developed for calculating life cycle emissions? Maybe you can talk a little bit more about just, you know, the role of EPDs and how, you know, how well established that tool is.
Yeah, I would say, you know, as far as life cycle, if you're talking about at least cradle to gate, you know, those product category rules for different products like concrete and cement do a pretty good job at setting that kind of framework. As far as looking at like use phase, we don't quite have a great way to keep that standardized and measured yet. And that's kind of why we're really, you know, first focusing on embodied carbon emissions rather than operational carbon emissions.
Yeah, and I'd even add a couple of things to that too, Sasha, is that one of the things that's really worth pointing out is that we really wouldn't be able to have this conversation unless there was innovation in the EPD world. You know, in the last, you know, 4 or 5 years, one of the real challenges with concrete is you have a concrete plant. If you're talking about those product specific EPDs that Caleb referenced, is that a plant produces, you know, thousands of different mixes. And so where a lot of EPDs have applied to more sort of stable standard materials where you could do that assessment at a certain cost, that doesn't map on well to a material where you have such variation. So there's been innovation in the field where you have more of this sort of digital upfront sort of platform that's developed. That's the main cost that allows a provider then within minutes to change a couple of different inputs and then generate an EPD for a particular mix. Had that not happened or evolved in the private sector, it would be really hard to sort of use EPDs for this purpose. And the other thing I would say too, that sometimes is maybe underappreciated even by us, is that EPDs are a standard that have been around for a while and continue to evolve, and private sector actors and municipalities are really kind of pushing the envelope, I think, about how they're used for concrete. But if you have states and really large purchasers come in and use EPD as their standard, that's going to force further evolution. That's going to actually only improve EPDs more if you have large government, states and federal, and even large municipalities using them. That's going to, I think, accelerate rates of innovation and improvement in EPDs themselves.
Thanks, Chris and Caleb. I'm hopping around here. Another question: how do you set the premium level or discount rate level of a high performance incentive?
Yeah, I can. You want me to start with that one, Caleb, or you can go ahead too if you want to.
Go ahead.
Yeah, sure. Yeah, I mean, part of it is in terms of the numbers that you set, for what's the threshold, and then where do where are you going to start incentives? You have to do the local work of figuring out what your baseline is for emissions. Again, you can't pluck that out of the air. If you're in Texas, it's going to be different because the mix and the inputs and the emissions from cement might be different from what the average is, in other places like, New York. So that data collection is really, really important. And so if you see something like Buy Clean, they phased it in terms of setting their mandate. First, they did data collection. That's giving them a picture of what the current baselines are, and then you can set your threshold. For the incentives, what we're looking at with New York is, I think it's similar with New Jersey, is that concrete is a commodity. It's a razor thin margins, right? So a little bit of extra money or compensation that can go a really long way, both for a performance bonus as well as a bid discount. If you come in at 2% lower than your competitor because of a GHG adjusted discount rate, that might mean that you win the bid. That's how tight it is. So you can do relatively little, 5%, very, very small amounts to trigger that can actually be really, really meaningful. I think the origins of the 5% that we put in the original ECLA bill and is still there under performance bonus, that we actually trace back to the federal highway program that Caleb actually told me about. I think that was the number. And then when we kind of proofed that in various different states with providers, that seemed to be an appropriate balance of not being too rich, but being rich enough to be meaningful as an incentive. So I don't know if Caleb, anything you wanted to add to that?
No, that was great. Yeah, thanks, Chris.
Given, as you just mentioned, that concrete is a commodity, so there's a question, given that concrete is a global commodity good with low margins, how can we A, prevent emissions leakage, and B, do we need a carbon border adjustment mechanism to protect against cheaper, higher carbon concrete imports?
Sasha, I think you know the answer to that better than us, but if you can also weigh in on that first if you want to, and then I'd be happy to put in my 2 cents too.
Well, I'll say, from NRDC's perspective, it's the beauty and part of some of these, procurement policies that they're looking to integrate climate performance into this decision making alongside cost, and it's in some sense irrespective of where the material is coming from, right? That climate performance is the goal is to embed that climate performance into these decisions. I think I can pass it to Chris and maybe to Caleb to talk about sort of concrete as a more localized product, as opposed to some other, energy or emissions intensive industrial building materials, like perhaps, steel and others that often come up in these conversations around Buy Clean and government procurement, where these sort of border adjustment mechanisms, are part of the complementary set of policies that we need to be thinking about. But what's so nice about a lot of these frameworks around, procurement is that, again, they're sort of agnostic to where a material is coming from. The premium is on, the material that can demonstrate that it has better embodied carbon emissions. But Chris, maybe you can talk about the uniqueness of concrete in this respect.
And a lot of it has to do with making the real sharp distinctions again between concrete and cement, which is the thing that Sasha and NRDC team and myself are sort of obsessed about right now, because through our last couple of years of advancing a low carbon concrete procurement policy, we realized that attracted a lot of attention for folks who wanted to solve other problems around cement. Concrete, I think in New York State, we got about 180 concrete producers locally. So most of the concrete is going to be locally. So a border adjustment wouldn't be appropriate for that. But for cement, which is a global huge industry, market share, I think is 5 different companies globally. Some of that is produced locally in state, but you might have it coming from places like Greece, China, or, Mexico, other places like that. So there, a border adjustment is really a great idea, I think. And Sasha, we need to think even more about that. I know there's some legal complexity around that on the state level, but there is really good, because one of the key things that is a real problem, which we shouldn't overlook, just from a climate perspective, but because these are commodities with such razor thin margins, competitiveness is a real issue. So you don't want to implement a policy that necessarily punishes or becomes too onerous for your plants that you might have in state, because the result of that is not going to be lower carbon. It's going to be making those plants uncompetitive, and then just having concrete producers buy from a lower cost from another place that might have really, really higher emissions. So whether we like it or not, there really has to be a partnership mentality, a sort of a how do we help and work with the local cement companies to rapidly accelerate their decarbonization? Because again, otherwise, if we don't, it's not really a victory. If you shut down a plant in New York, all that means that the cement's going to come from somewhere, and it's probably very likely to come from some place that has dirtier cement. So those are just a couple of things I would add to that.
And maybe I can just jump back in on the concrete side. One of the reasons we think that, aside from a great climate policy, this is potentially a great economic development opportunity is that, if a state like, New York or New Jersey incentivizes its local concrete makers to, innovate and come up with, different mixes, do that stacking of different, measures and interventions to be driving down their GWP scores, they can potentially be, selling that product into a regional market, right? And then the states that have these policies on the books become real centers of innovation, in this space. A whole new kind of industry could emerge there. So I think there's a real economic development case to be made around some of these policies as well.
And I mean, really, when you look at the emissions from U.S. cement versus some other countries, we're actually among the higher emitting per ton of cement. We use a higher amount of clinker in our cement, and we use a little more energy. And so, we actually have a big opportunity here to, try to drive down the emissions of our cement products.
We have about 5 minutes left, so I'm going to ask 2 questions at once, and you guys can take them in whatever order you'd like. So the first is, are private companies or others in the space using these low carbon procurement policies, universities, technology companies, and so on? So question around the role of the private sector. And then at the same time, we have a couple of questions about the role of the federal government here. So could you just elaborate on what that role might be? Can you talk more about how federal rulemaking and or legislation can work in tandem with state and local policies in this space?
Yeah, and on the federal side, obviously, Sasha, we're thinking about this all the time because there are real linkages, and Caleb can also speak to, like, federal funding for concrete mostly flows down to states anyway, you know what I mean? So they're linked together. But just on the first point, it's worth noting that, yeah, private sector is absolutely leading, I would say. I think it's really, one of the inspirations for the original LECLA discount rate came from a program that we learned about that Microsoft did with Skanska when it expanded its campus a few years ago. They introduced this idea of, let's, at the bidding stage, actually factor in EPDs and global warming potential, and make that part of our decision making, make that part of the competitiveness of the project. And so that, the Netherlands project, and a couple of other ideas fed into what we're proposing at the public sector level. But you have LinkedIn, you got I know in Hudson Yards in Manhattan in New York, the Disney, I was reading about that recently. They're build out. They're requiring low carbon concrete. So I think you see a lot of that around in the country is the public sector leading, and that can really help inspire, I think, public sector policy. Caleb, I don't know if you wanted to add anything. I know you did a real deep dive in federal policy around concrete a couple of years ago that educated me. And Sasha, you know a heck of a lot about that as well. So maybe you guys can speak to that.
Yeah, it's like Chris alluded to. A lot of the money through the funding to the Federal Highway Administration actually goes to states through various programs, like one I mentioned earlier, the National Highway Performance Program. So, the idea would, at the federal level could be to, all funds, all projects that are funded with that money need to go through some kind of procurement policy. But, it's kind of like what we were talking about localized EPD data. It would be really important that, we're not setting a federal emissions threshold, and that we keep some of these things that still at a localized level.
And I'll just maybe add that, this is an incredibly live issue at the federal level. Just earlier this month, the General Services Administration put out the first ever standard around lower carbon concrete procurement. They're as of today, as of immediately, they're going to be including that standard in bids for some of the projects that they are directly overseeing. And it's a really important first step. I think it shows just the incredible momentum around these types of policies at the local, state, and the federal level.
And two other things that you and I are obviously focusing on a lot, Sasha, is, well, one thing is, Build Back Better, I know, is there's a proposal for tax credits or subsidies for EPD setup, I think not just at concrete facilities, but steel and other major emitting materials. If that happens, then that takes that off of the balance sheet for states. We were saying we were proposing tax credits in New York and rebates. If the Fed picks that up, that's one cost that the state wouldn't have to do. And that'll flood the sectors with data, which is fantastic that you can compare across states. And then the other thing that Sasha and I really are into is this, when we talk about the accelerated evaluation, those constraints that those agencies have are real. Some of them, it costs money to be able to accelerate evaluation, really look at, testing low carbon materials. So we've kind of talked about this idea of almost like the way the FBI has a national crime lab that local law enforcement can sometimes send materials to for help. We like the idea of a similar type of lab for low carbon concrete, where the federal government, in various different ways, this could be done either centrally or in a distributed way, could try to provide resources, expertise to actually help defray the cost or add additional technical capability for that accelerated evaluation. We think that would have a big impact, we think, on the state level.
So I think that's a good place to close out here. So, incredible innovation happening at the state level that's, really laddering up, trickling up, to the federal level, and then really an important role for the federal government, in a lot of this to do certain things that could really lift all boats here. So really, I think a very exciting time for these procurement policies, and concrete, I think, is at the top of the priority list for many of them. So thank you everyone for joining. Thanks to our authors and presenters, Chris and Caleb. Like I said, this webinar was recorded and we'll publish it on our website and email it out to all the registered participants for this event, alongside a link to our report, which has a lot more detail on everything that Chris and Caleb covered, but we really wanted to make it really a practical, user-friendly guide. So please do take a look, and please do be in touch with any feedback or questions. Thank you so much.
Thank you.